Here we have an ellipse with the distance from the center to the vertex is A, and then distance from here to here is B. So half the major axis is A and half the minor axis is B. And we want to show that the area of this ellipse is equal to A times B times pi. And so for this ellipse, the center will be at the origin, which is 0, 0. And so the equation of the ellipse will be x squared divided by a squared plus y squared divided by b squared equal to 1. And so this is an ellipse with the major axis parallel to the x-axis. So we have the equation is this form. And then let's solve for y. And so if we subtract both sides by x squared minus a, x squared dividing by a squared, and so we end up with y squared over b squared is equal to 1 minus x squared dividing by a squared. So subtract both sides by x squared dividing by a squared. And then multiply both sides by b squared, multiply both sides by b squared. So multiply the left side by b squared, x squared, and then multiply the right side by b squared. And then now take the square root of both sides. And then we will end up with the plus or minus. Right here. The plus would be the top half of the ellipse, the minus would be the bottom half of the ellipse. And so we have the square root of b squared, which is just b, and then what's left inside is 1 minus x squared divided by a squared. And now let's get a common denominator of a squared. So 1 is the same as a squared dividing by a squared. So now we have a squared minus x squared dividing by a squared. And then the square root of a quotient is just square root the top dividing by square root the bottom. And the square root of a squared is just a. And so we end up with plus or minus b over a times the square root of a squared minus x squared. Once again, the plus, that's the top half of the ellipse. The minus, that's the bottom half of the ellipse. And our objective is to get the area of this ellipse, so we can just find area of the top half and then multiply it by 2. So the area of the top half, so the area up here, would be the integral from this from here to here is a. So this is a right here, and so this would be negative a. So this point right here would be the point a0, and this point would be negative a0. And therefore the area of the top half of the ellipse would be the integral from negative a to a. So it would be the integral from negative a to a, and then the equation of the ellipse for the top half of the ellipse is y equal to positive b over a times the square root of a squared minus x squared. And therefore area of the top half of the ellipse would be the definite integral from negative a to a, and then the function is b over a times the square root of a squared minus x squared. And so if we can find this, then this will give us the area of the top half of the ellipse, and then to get the area for the entire ellipse, we would multiply this by 2. And so now this is just the same as this. The b over 8 is just constant, so we can move it and place it in front of the integral sign. And now we need to find the integral for the square root of a squared minus x squared times and then dx. For this type of integral, let's use trigonometric substitution to get this type of integral. And so recall that to use trigonometric substitution, if we have an integral of the form a squared minus x squared, then the suggestion is to let x be a sine of theta. And so if we let x be sine of theta, then sine of theta will be dividing both sides here by a, then we get sine of theta to be x over a. And then also from here, we also have a sine inverse. Of x over a is equal to theta. So if sine of theta is equal to x over a, then sine inverse of x over a is equal to sine of theta. And that's the definition of inverse function. And since we want to find the integral of the square root of a squared minus x squared, and so here we have the square root of a squared minus x squared, and so this is a squared, but x is a sine of theta, and so here we have a sine of theta squared. And then this is the same as this. This is the same as a squared minus sine squared. The common factor here is a squared, so let's factor out the a squared. And what's left is 1 minus sine squared. Recall from trigonometry that 1 minus sine squared is cosine squared. So the square root of a squared is a. The square root of cosine squared is just cosine. So the square root of a squared minus x squared is a cosine of theta. And so now we do the derivative of x with respect to theta. So the derivative of a cosine of theta here we have x is equal to a sine of theta. And so the derivative be a, and then the derivative sine of theta is just cosine of theta. And then from here we have the dx is equal to a cosine of theta times d theta. And so far we have the square root of a squared minus x squared is a cosine of theta, and then we have dx is a cosine of theta d theta. And therefore this integral right here, the integral of a squared minus x squared dx, the square now becomes this. The square root of a squared minus x squared, that's a cosine of theta. So we have a cosine of theta. dx is also a cosine of theta, d theta. So we end up with a times a, which is a squared. And then cosine times cosine is cosine squared. And then now we need to find this integral. We need to find the integral of cosine squared of theta. And so first, let's find the cosine of 2 theta. So here we can use u substitution. So let u be 2 theta. And so du d theta be 2. And so we have du is equal to 2 times d theta. And then multiply both sides by 1/2. Multiply this by 1/2. Multiply this by 1/2. We get 1/2 du is equal to d theta. And so the integral of cosine 2 theta now becomes 2 theta, we call it u, so this becomes cosine of u. And then d theta is 1/2 du. And so we get 1/2 times the integral of cosine of u, but recall that the antiderivative of cosine is just sine. So we get 1/2 sine of u. But u is 2 theta, so we get 1/2 sine of 2 theta. So the integral of cosine of 2 theta is 1/2 sine of 2 theta. What we after is this. We want the integral of cosine squared. Cosine squared, from trigonometry, we have an identity. Cosine squared is the same as 1/2 plus 1/2 cosine of 2 theta. And so the identity for cosine, one of the trig identities for cosine squared is 1/2 plus 1/2 cosine 2 theta. And the antiderivative of the constant 1/2, here we're integrating with the respect to theta. So be 1/2 times the variable theta, which is 1/2 theta. And then this is 1/2. And then the integral for cosine of 2 theta. Cosine of 2 theta is 1/2 sine of 2 theta. So the integral of cosine squared is 1/2 theta plus 1/2 plus a half times a half sine of 2 theta. So this is 1/2 theta. A half times a half is a fourth. And then from trigonometry, we have an identity of sine of 2 theta. Sine of 2 theta is the same as 2 sine theta times cosine theta. And so right here all together we have this. A 4 times a half is just 1/2. So the integral of cosine squared is 1/2 theta plus 1/2 sine theta times cosine of theta. And now back to our integral. So the antiderivative of cosine squared of theta is 1/2 theta plus 1/2 sine theta cosine theta. And then we have the a squared in the front. So this is a squared times 1/2 theta. So a squared times 1/2 theta. But earlier we have shown that theta is sine inverse of x over a. Theta is sine inverse of x over a. So here we have a squared times a half times sine inverse of x over a. And then here we have a squared times 1/2 sine of theta cosine of theta. And now let's go find sine of theta and cosine of theta in terms of x, since the original problem was in terms of x. From here we have sine of theta is x over a. By definition of sine, sine is opposite over hypotenuse. And so this is the angle theta. The opposite side is x. The hypotenuse is a. So this is the angle theta. The opposite side is x. The hypotenuse is a. And then we need to find this side right here. So this is called the adjacent side. So let's call the adjacent side here, let's call it y. And so we have x squared plus the adjacent side. So we'll call it y, and then we have y squared is equal to a squared. And so subtract x squared from both sides. And then take the square root of both sides, and we get y equal to the square root of a squared minus x squared. So the adjacent side is the square root of a squared minus x squared. So this side right here is the square root of a squared minus x squared. And we know the sine of theta is x over a, and then the cosine of theta is adjacent over hypotenuse. So the cosine of theta will be the square root of a squared minus x squared over a. Cosine of theta is the square root of a squared minus x squared over a. And so back here we get a squared times 1/2. Sine of theta is x over a. Cosine of theta is the square root of a squared minus x squared over a. So right here we get 1/2 a squared times sine inverse of x over a. This is a squared, and then this is a times a, which is also a squared. And so a squared divided by a squared is 1, and so the a squared drops out. So what's left is just 1/2 times x. 1/2 times x is the same as x over 2 times the square root of a squared minus x squared. So the integral of the square root of a squared minus x squared is all of this. But now we need the area of the top half of the ellipse, which is the integral from negative a to a. Up b divided by a times the square root of a squared minus x squared. We have just, so the b over a, let's move it outside. And then we have just shown that the square root of a squared minus x squared is all of this. And so in the place of the integral of a squared minus square root of a squared minus x squared, we have this. And now we need to evaluate this expression right here from negative a to a. So first, in the place of x, we have a. And then for the lower limit of integration, we do minus, and in the place of x, we have negative a and negative a. A divided by a is 1. A squared minus a squared is 0. So this part will be 0, and we get sine inverse of 1. Negative a divided by negative a is negative 1. A squared minus a squared is 0, so this part will be 0, and we get sine inverse of negative 1. And recall that sine of pi over 2, sine of pi over 2 is equal to 1. And therefore sine inverse of pi over 2, sine inverse of pi over 2 of 1 would be pi over 2. So sine inverse of 1 is equal to pi over 2. And then similarly, sine inverse of negative 1 is negative pi over 2. And so here we get b over a times 1/2 a squared times pi over 2. And then this is minus negative, so it becomes plus. So this expression and this expression, they are the same. So we can just write it as 2 times the first expression. 2 times 1/2 is 1. 2 times 1/2 is 1. And then what's left is b over a times a squared times pi over 2. A squared dividing by a is just a. And then we have a b here, and then we have 1/2 pi. So altogether is 1/2 times a times b times pi. So area of the top half of the ellipse is 1/2 a times b times pi. The area of the top half of the ellipse is 1/2 times a times b times pi, and therefore area of the entire ellipse is 2 times 1/2 times a times b times pi, or just a times b times pi. And this is the area of the ellipse.